So hi guys, welcome back to my channel. So today we're gonna continue with another topic in calculus 2, and today's topic is the improper integral. So what is improper integral? So it is the definite integrals over infinite interval. So it can be like from 0 to infinity. So this one is improper integral, and also the integral um, that has a infinite discontinuity. So it has a discontinuous in a function. So so we can let's consider the area under the curve of fx equal to 1 over x squared from 1 to t. So a equal to the integral of from 1 to t of 1 over x squared dx. So it will equal to minus 1 over x from 1 to t, and it will equal to minus 1 t minus negative 1 over 1, and it will give us 1 minus 1 t, and it will equal to 1 because when t increase to when it's approach infinity, 1 over t will approach 0. So 1 minus 0 will be 1. So that's why we have the answer is 1. So we will have a definition. If we have the integral from a to infinity of fx dx, it will equal to limits when t approach infinity of the integral of a from a to t of f of x dx. And in a similar way, we will have the integral from minus a negative infinity to p of f of x dx will equal to the limits of t will approach negative infinity of the integral from t to p of f of x dx. So we have this formula, and you guys have to remember this in order to do well on this topic. So so these improper integral would be convergence or divergent depending on whether the limits exist or not. So if these one of these limit exists, it will be divergent, and if it's not exist, it will be divergent. I mean, if this exists, it will be convergent, and not exist will be divergent. So now moving on to some next some properties. So we have a really common property that I think you guys know from calculus 1. So if we have the integral of from negative infinity to infinity of f of x dx, so this one will be equal to we can also it will equal to the integral from negative infinity to a number a of f of x dx plus the integral from a to infinity of f of x dx. And as long as both integral are convergent, so this one have to be convergent. So both of these will be have to be convergent, and we have this properties. So let's moving on to one of these example for this topic. So let's example number 1, evaluate the integral from 1 to infinity of 1 over x dx if possible. What is mean of saying it possible, because if it is divergent you cannot evaluate it. Evaluate mean the final answer has to be a number. So now we will apply the formula over here to this problem, because we have the infinity in the interval. We will using the this formula. So 1 over x dx will go to the limits of t approach infinity of the integral of 1t 1 over x dx. So this one will equal to the natural log of absolute value of x from 1 to t, and we will expand it now, and we will have natural log of t minus natural log of 1. So natural log of 1 will be equal to 0, as you know. So we will only have the limits when t approach infinity of natural log of t, and when t get bigger and bigger, the natural log will be bigger and bigger. So actually natural log is the logarithm function. So when t really big, the natural log function will get really big, and that's why this one will approach, this limit will approach infinity, and as t approach infinity, a natural log of t will approach infinity, and therefore it is divergent. So we will have the answer for this example is divergent. So now moving on to another example. So example number 2, evaluate the integral from negative infinity to 0 of x e to the power of x dx if possible. So now do the same thing. First apply the formula that I provide you on the really early of the video, and this integral will equal to the limits when t approach negative infinity of the integral from t to 0 x e to the power of x dx. So now you first evaluate this integral. First evaluate this the infinite indefinite integral. So first you have to find the integral of this. So you see this is the products of two functions. So what is remind you of? So it's remind you about integration by parts, right? The first topics of calculus 2. So let's do it. Let's evaluate this indefinite integral by using integration by parts. So let u equal to x and dv equal to e to the power of x dx, and we have du equal to 1 dx and v equal to e to the power of x. And by the integration by part, the first term will be u multiplied by v, so it will be x multiplied by e to the power of x, and minus the integral of v du, so it will be e to the power of x dx, and it will give us x multiplied by e to the power of x minus e to the power of x. And so this one will equal to e multiplied by e to the power of x minus e to the power of x in a bracket from t to 0, and this will equal to limits of so the first one will be 0 minus e to the power of 0 minus t e to the power of t plus e to the power of t. So it will give us something like this: et minus t et minus 1. So now, because t approach the negative of infinity, so it will get really small and small. So as you remember the graph of this function, right? So this is the like this is like 2 TB. It's like this function. It's a like a power function, I think. So and it will on the graph it will something look like this. So when t approach infinite approach negative infinity, the value will get closer and closer to 0. So this one will give us 0, this one is 0, this one also 0, and this is minus 1, and the final answer is minus 1. It's a negative 1. So overall the answer is minus 1. So this this improper integral is convergent, right? Because and it's convert at negative 1. So that is all about improper integral. All you need to know is this formula. Thank you for watching.